This is my post-lab for Lab 2 Projectile Motion. For this lab, we are observing an object moving in a projectile motion. We used the Tracker app to record this motion. We then used code to create a model of the motion. We made a model both with and without drag. I then created a graph to compare all three of these. The main physics principles we used for this lab was Newton's second law. Force equals acceleration times mass. This is the video of my experiment. For this experiment, we threw a paper ball so that it moved in a parabolic motion. The initial condition for the experiment and the model is that the ball is already moving at a constant speed. The system is the ball of paper, and the surrounding is everything but the ball. This is the model I created using code to represent how the ball moved. The model shows a parabolic representation of the experiment. The blue ball in the model represents the paper ball, and the green arc represents the path of the ball. Potential sources of error were that the camera was not parallel with the throw, and that the actual weight of the ball was incorrect. It was hard to weigh the ball because it didn't weigh much. This is the code I wrote. Well, this is part of the code I wrote. This is like the important stuff. I set the initial variables to the data based from the Tracker app. This includes the initial position of the ball, where it's already moving at a constant speed, and the velocity of the ball, which in the x direction was 1.75 and the y direction was 2. I also set the delta t to the time between frames, and then I created equations for the gravity, the drag, and the net force. I then used the velocity and position update formulas to move the ball. I also created a drag component to match whether I wanted the drag or not. So when I wanted the drag, I would include it, and when I did not want the drag, I would set that component to 0. This is the graph I made to compare all three. The experiment is that the numbers that I got from the experiment is the blue line. The model without the drag is the red line, and the model with the drag is the yellow line. The red line and the yellow line are very similar, and it's kind of hard to see where they are, but towards the end you can start to see them to separate a little bit. It's not surprising that they're very similar because the only thing that changed was a little bit of drag. The model started off okay, but then the experiment went higher than the model did, and the gap over time grew. Conclusion. This was to answer the questions in the post-lab. Do any of the models predict the terminal velocity? No, my model did not predict any terminal velocity, as there was always a force dragging it down. If the object were initially thrown straight up in the air with the same initial speed as the experiment, how long would it take the ball to reach the table? The ball would reach the table at the same time because there was not a change in the force in the x-axis, so it would not change how long it took to reach the table.